chemistry, right? So let's not say welcome to chemistry. Let's do.
Whoa, what?
Well,
oh, I want to.
All right. Now that's going to be up there forever, right? Should we call this magic?
Yes, it's magic.
I agree. Chemistry is all about magic. We have to agree on it. No. There's something else going on here, and you will eventually find out the reason that this happens the way it does. In this class, we're welcoming you to chemistry, and we're just going to start off by seeing what chemistry is and what it is not. Over the course of this year in chemistry class, you're going to be covering a lot of different stuff. First of all, chemistry is what's going on when you see these various different reactions that you're familiar with. You've seen a log burning in the fireplace. We're going to explain how that happens this year. Iron rusting on a car, perhaps, that doesn't have a good paint job. We'll explain that. Ow, you get a cut. Your mom puts peroxide on it. It bubbles on the surface of the cut. We'll explain that this year. These different things that you've seen in the past and might wonder what's going on, we'll give an explanation. That's chemistry. We're going to be thinking about how energy makes a difference, because our energy is basically chemical reactions. How hot packs can work to generate heat, how nuclear power works in order to give us the energy that we would use for electricity, batteries, fuel cells. The energy production is based off of chemistry. Chemistry is going to involve a bit of math. Now, not the scary kind that has different variables in algebra, but a very basic form of mathematics that's simple conversions. We'll be figuring out how many atoms there are in a substance. We'll be figuring out how much of a chemical we could actually make. We could figure out how cold something will be when it reacts. These are the kind of mathematics we'll do, and the mathematics themselves aren't that tough, as long as you can just, as long as you have a good grasp of algebra. Give me a question. Oh, do you write this stuff down? I don't need you to write this down. This is not something that I'm going to be testing you on. I want you just to be familiar with what chemistry is and what it's not. One of my favorite parts of this class is we get to explain how a lot of common stuff works. Why is it that soap cleans us better than water? How is it that when you flip the switch, the light bulbs work and let us see? How is it that refrigerators keep my food cold? What the heck is fire anyway? These are the kinds of things we hope to address this year. What chemistry is not. It is not magic, it is not potions, and it is not bomb making. Okay? I always have people that are to blow something up. The answer is May. Make it through May. We'll blow something up in May. But you have to do good until then. Got it? Okay. The lab that you're going to do today is one of the basics of observations. When we talk about using the scientific method, basically it's a way of solving problems. In the news right now, you might have heard a lot of stories about politics. Politicians trying to run for president, trying to be elected to office. One thing politicians do is they'll stand up in front of you and say, I know the answers. You never hear a politician say, I don't know the answers. You always hear them say, I know the answers. And then what they'll do is they'll look around for evidence to prove them right. That's exactly what scientists don't do. Scientific thinking is not stating that you're right and then looking for evidence to prove you're right. Please don't write this down. You'll have your chance later on. Scientific thinking is, first of all, gathering the evidence, making your observations, thinking about things a little bit. And then not stating, this is how it works, but rather stating something called a hypothesis. It's maybe how it works, but maybe not. Let's test it and see it from words down to just abbreviations.
Yes.
BS? Are you calling this class BS? Sounds good to me. Baking soda is BS. Yeah, you heard me say it first. Baking soda is technically sodium bicarbonate, but I don't need you to write this down. The chemical formula part of it, let's not worry about that so much today. Baking soda, something everyone has in their house for baking. We'll call it BS. The second chemical you have also comes from your kitchen. It's called table salt. You might actually know the chemical name of table salt.
Sodium chloride.
Sodium chloride is right, but we're not going to call it sodium chloride. We're not going to call it table salt. Let's abbreviate table salt. Let's call it TS. TS is good for me. We're just making abbreviations. That'll be easier for us. The third chemical that's in those containers is one that we probably don't use here in the Bay Area, but our friends up in the Sierras might. It snows there, and it could make ice there. And so what can you do to remove the ice?
Rock salt.
Yeah, you can put kind of salt on there. Now, rock salt could work, but something that works better is road salt. It's a slightly different. Rock salt is basically dirty sodium chloride. Road salt is a chemical called calcium chloride. Abbreviate road salt for me.
RS.
Sounds good. RS will be road salt. The chemical is calcium chloride. But again, I don't need you to write down the real chemical formulas. That's not necessary. The last solid white chemical is one you don't associate normally with being a solid white chemical. You'll eat it today in many different forms. You might have it in a glass of orange juice. You might have it in a sour tart candy. You might have it in a lot of different forms. Not sugar, but it tastes sour. And it's in oranges and lemons. They're citrus fruits. It's called citric acid. But if you remove the citric acid from the orange, it becomes a dry white solid. What do you think we should abbreviate citric acid? Ca. These are the 4 white solids. I didn't do this, but what I want you to do is, by the side, could you please write down, these are all solids. Now, we also have one liquid, and the liquid that we're going to use is mostly water. But there's a little bit of the juice of a cabbage in here too, a red cabbage juice, and it makes it have some unusual properties. So we'll call it cabbage juice, and you'll abbreviate it. CJ sounds good, cabbage juice. This is our one liquid that we're going to use. So I'd like to give you a bunch of rules, but frankly, I'm not. Today, you don't have any chemicals that are going to accidentally blow up in your face or anything like that. I just want to kind of keep it simple, kind of keep it working well. Here's the only rules I'm going to give you. Number 1, I'm going to ask you to wear your safety glasses, and if you look over here in this wall, right over here, guys, you see it? That's where the safety glasses are kept, right over there. Green ones, if you have eyeglasses, you can have the red ones if you don't have eyeglasses. Put them there, pick them up from there, take good care of them, but I want you to wear them during this experiment, please. Second rule, you're going to combine materials. Solids don't work well with solids. There's no medium. So when you combine them, put solids in your Ziploc bag first, followed by the liquids. Liquids last. Rule number 3. You have 2 Ziploc bags. Picture that I'm part of this group, so while we're experimenting with one, somebody else is cleaning and drying out the other. You always want to start with a dry Ziploc bag, but you're going to have to reuse them over and over again. So dry the Ziploc bag between trials. Try to use small amounts of chemicals. Now by small amounts, I saw some people using this much. I mean something where you can see it and measure it, but something where you're not using half the bottle. The idea is the bottles to get us through several classes. One of the reasons we use Ziploc bags like this is you can see through it, but there's something else you can do through it as well. You can see through it, but what else? Because this is a very thin, flexible material, I can also feel what's going on inside of this thing. I could see through a glass speaker, but I couldn't really feel what's going on instead. So we're going to ask you when you observe to use multiple senses in this case. Your eye, your ability to see, but maybe also your ability to hear and feel as well. Okay? So keep all your senses active in this case. Use small amounts of chemicals, but enough to where you can actually feel what's going on inside those groups. After you add a chemical, please rinse off and dry the scoop before you add a new chemical. Just like if you and your friends were together and one of you had a spoon, you wouldn't hand the spoon to somebody else then pass it around, right? You would clean it off first. For the same reason, clean off your spoon. Some of the chemicals react with stuff in air. So when you take something solid out of the bottle, please seal the bottle again. And finally, and most importantly, please wash your hands when you get done.